utilizing Vital Energy's unique installation equipment. Before a band muff joint can be installed, the very first task is to do a continuity test on the pipework, using the surveillance wires as conductors to check and verify that there are no earthing faults or breaks in the wire or wires touching metal, causing the circuit to short out. A fault may be present in the pipework, resulting from transportation or installation. The test is passed, and the surveillance wires are crimped together securely and then soldered. The next step is to place a hydroscopic felt pad around one of the wires. Should there ever be a fracture or a fault at this joint, the pad will quickly absorb moisture and trigger the surveillance alarm. The other wire is a signal wire and is insulated from the steel pipe using these plastic bridges. The advantage of this wiring system is that a fault can be detected quickly, and with the aid of an impulse reflectometer, its location found with an accuracy of within 1 meter of its position, meaning that it can be dealt with promptly, reducing the development of expensive future repairs. Adhesive tape is used to keep the insulators and padded wire in place until the final stages of the installation, when the wires will be surrounded with a liquid that is poured into this cavity. It expands into a dense foam and sets hard to provide a layer of insulation between the inner steel service pipe and the band muff, thus creating a perfect bond between the service pipe and the muff's outer casing. A metal bar or bridge is then hammered into place. This is to support the lateral overlap of the band muff. Screws are then screwed in until they meet the steel pipe and adjusted so that a bridge is formed at the correct height to support this overlap. The protruding screws are then ground off to make a level surface. The pre-insulated pipe outer casing and the band muff are made of the same material, high-density polyethylene. To help the fusion and keying of the band muff to the existing pre-insulated pipework, strips of about 15 centimeters wide around the circumference of each pipe are wire brushed to create the ideal keying surface. These cleaning strips protrude past the edge of the installed joint, enabling the final quality checks to show that the joint area was correctly cleaned prior to the installation of the joint. The lateral overlap on the band muff has the same treatment. The fusing together of the band muff and the installed pre-insulated pipework is done by passing an electric current around the muff exactly where the seals are to be made. So, for this reason, an insulation pad has to be secured over the metal bridge to prevent a short circuit. Here on the inside of the muff you can see rough or embossed strips in the form of a border. Beneath this, embedded in the plastic, is a multiple wired electric circuit. The number of wires varies depending on the size of the muff. When the current is passed through this multiple circuitry, heat is created, and at a certain temperature it melts the polyethylene, causing it to bond and fuse with its contact layer, making one solid, unbreakable unit. The benefit of this type of wiring ensures that if a wire gets damaged during the welding process, the quality of the finished joint wouldn't be affected, unlike the joint systems offered by other companies, which utilize a one-wire system. In this case, if the single wire should be damaged, then the welding process would fail and require the joint to be cut out and removed. These are the terminals on the muff that connect the electricity. A template is used to stencil in the position where the edges of the muff must overlap. This is directly above the bar or bridge. Without these marks, positioning the overlap of the muff accurately wouldn't be possible. All connecting surfaces are wiped with an alcohol-based solution that removes all the dirt and grease and any residue that may interfere with the fusion process. The aim is a clean installation, which is easily achievable using this open joint system which is wrapped around the casing, thus removing the problems associated with a closed joint system. A closed joint system requires the muff to be slid into place later, when all the work is completed. During this time it will collect dust, moisture and other spoils, creating poor conditions for fusion and increasing the chance of a joint failure. The open joint band muff can be used for carrying out repairs on existing pipework and, most importantly, will not affect normal operational use. The band muff can now be put in place and aligned using the stencil marks. Once aligned, it is clamped firmly at each side, using a pneumatic fixture tool. Each clamp has an inflatable collar on its underside. The clamps are now in their correct positions, above the band muff's electric strips where the pressure has to be applied. Air pipes are connected and compressed air is pumped into the clamps, sandwiching the overlapping edges of the joints very tightly together. The air pressure will be monitored by the welding computer to ensure the correct pressure is evenly applied. Now the electric cables from the computerized welder are connected to the band muff's terminals. The welder is switched on and a muff report is taken from the computer screen. This report provides the information compared from the readings at the start to those at the finish, relating to heat levels, the duration of the heating up period, the welding time, and the cooling off period. The whole process takes approximately 20 minutes. It is very important to check the resistance of the wires, as this will indicate if any wires have been damaged during the welding process. As a rule, a minimum of 80% of the wires must be intact, otherwise the joint would need re-welding. Also, re-welding would be necessary if there was an interruption of power during the welding process. After the welding process has been completed, the cables are disconnected and the air pressure is released. Now it's safe to remove the pressure bands. When the joint has cooled down after welding, it is pressure tested with air. On this particular joint, a third hole has been made on the outer casing due to the angle at which the pipe has been installed. This will ensure the joint is fully vented during the foaming process. While under air pressure, soapy water is sprayed over the welds to check for leaks. Before the joint can be filled, the electric terminals are snipped off and pushed inwards through their holes, creating an obstruction-free passage to the inner cavity. At this point, the insulation liquid compound is thoroughly mixed and funneled through the holes. This starts turning into expanding foam almost immediately, so it is critical that these special red plugs are hammered in with little delay. They act as vents, releasing the air and at the same time restricting the discharge of foam. This ensures that the dense foam insulation surrounds and fills the cavity from bottom to top completely. Small amounts of foam bubble out, creating globular caps above the vent plugs. After a set period of time, these globules set hard and can be removed. The plugs, having done their job, are also removed. Any residue from the process is then cleaned off the surface. Now the fill holes are countersunk and any debris removed. An electric plug tool is used, which heats the hole and its polyethylene plug at